Hello, welcome to our channel again. So I'm Suraj with a new video of mine, and today we are going to continue our series of the vector operators. So I have made two videos on the vector operators, which is on the divergence, curl, and the gradient. So in this video, we are going to discuss about their fundamental theorems. That's why the topic is fundamental theorem of vector operators. So if you're not familiar with the gradient, divergence, and curl, so I will put down the playlist of my vector operators in the description box. You can watch that particular video. So in this video I'm going to take a quick recap of what is the gradient is, so that you can understand it in a good way. So quick recap of the gradient, then we'll discuss about their fundamental theorems respectively. So start our today's video. First of all, what exactly is the meaning of saying gradient? So let's understand it. So suppose that you have any of these scalar functions. So let's say I have taken any of the scalar function t here, arbitrary t. So if t is any scalar functions, let's say t be temperature. Let's say t be temperature. Suppose that I have made a room here, okay? It can be very good visualization of the gradient in this manner. Suppose that there is a room and I put here the heater. H means heater, okay? So if there is a room, if I tell you that where the temperature is very more in that particular cases, so the temperature will be higher in that region in comparison of this particular region. Is this true? Yes, this is true. So the meaning of taking the gradient of any scalar quantity is that if you take the gradient of temperature here, so if you take the gradient of temperature at this point, what you will get is that the maximum increase of that particular scalar in that particular point. So at that particular point, the maximum increase of the temperature is in which direction? Towards the heater. It means the direction is like this, towards the heater. So this is the meaning of the gradient. It will tell you that the maximum increase of any, here I'm taking temperature, you can take any of other examples. So meaning of taking the gradient of the scalar operators is means that at that point, what is the maximum increase direction of that particular physical quantity? So in this case, it is the temperature. It means the maximum increase of direction of temperature is in the direction of the heater, and that exactly was the gradient means. So in gradient, divergence, and curl, there is a vector operator called the nabla operator, which is denoted by this particular symbol. So this is the symbol of the nabla operator. So this is t is a scalar quantity. When you apply this to this is what called the gradient. So this is what so-called gradient. Okay, you have understand what gradient is. Now we are going to discuss about their fundamental theorems of the gradient. So what the fundamental theorem of gradient is saying is that suppose that okay, the fundamental theorem of gradient is states that when you take the line integral from, let's say, point A to point B of this particular operator, taking the line integral of this particular gradient that we obtained, dx is equals to the t of B minus t of A. So this is the fundamental theorem for the gradient. So what is this exactly telling? So suppose that, let's take an example, because example can clear this concept in a very good way. Suppose that you take the temperature is dependent upon the x-axis, x square. Let's say, what do you mean? When you take the gradient of this particular temperature, it is obvious that it is will become 2x. Why? So if you're not familiar with this, then check my video on the gradient. So if you take the gradient of this particular temperature, it will become 2x here. Okay. Now what we have to do is that 2x is there. So suppose that I want the integral from, let's say, point, let's say I denied a point from 0 to, let's say, 0 to 2. 0 to 2, I want the gradient of t dx. What the thing is, what is the value of this particular integral? So there are two ways. First of all, you can do by this direct method, and second is by this fundamental theorem. So if I substitute here the values of the gradient here, 2x, so I will go substitute this value, what you will get is that it's integral from 0 to 2, 2x dx, 2x dx. So what is the value of this particular integral? So let's see here, 2x square, here is 2x square divided by 2, and you have to put here 0 and 2. So this 2 and this 2 will exactly cut out, and if we put here, this is what equals to the 4. So after evaluating this integral, it is equals to the 4. And by the fundamental theorem, the answer seems to be very easy. How? So let's see here. Now with the fundamental theorem, how we can evaluate this integral is like 0 to 2, 0 to 2, sorry here, 0 to 2 of the 2x dx. Okay, so this is the thing. So using the fundamental theorem, how we can evaluate this very easily. So integral of 2x dx, two methods. First of all, direct integration methods gives us 2. What the fundamental theorem says is that just put down here 2 and the value of x as 2, because you can see here it is tb and b here is 2. So 2 into the b, which is 2, and which is what equals to the 4, minus t into a, minus t into a. So t is 2x, and you know that x initially is 0. So this will become 0, will not. So this is what the fundamental theorem says. Here it gives 4 without evaluating much integral, and by integral it is also 4. It means we verified the fundamental theorem of the gradient. So this is a typical example of saying that what exactly meaning of the fundamental theorem of the gradient. So just like this, there is also a fundamental theorem of the divergence and curl. But in this video, I will only discuss about the divergence. Curl is a bit more advanced topic, so I will do in a separate video. So as you can see here, by taking the fundamental theorem of the gradient, the integral is a very much simple, very easier than evaluating is like a simple integral. Okay, so this answer gives us the 4. So now let's move to our the fundamental theorem of the divergence. So let's move our fundamental theorem of divergence. So fundamental theorem of divergence is also same like this. What it says is that, first of all, what is divergence? Okay, so divergence is basically thing like, suppose that there is a vector quantity, it is says that how much vector quantity is diverged from a point. Like suppose that there's a vector quantity which is like this. So this is called the positive divergence. So if you want to more detailed on the divergence, please watch my videos on the divergence. Okay, so what now we can do here is that the divergence fundamental theorem says that suppose that there is an, let's say t also, so t. So here t is not the scalar, here it is a vector, because the gradient can be only taken of the scalar while divergence can only be taken of the vector, not a scalar. So here t is a vector, not a scalar. So if you take the divergence, it means the dot product of t into this particular vector, it is called the divergence. And as you know from a basic vector, formulation, this is called the dot product between two vectors, and dot product between two vectors gives a scalar. It means taking the divergence of a vector quantity is a scalar, because as you can see here in this particular diagram, it has a multiple directions. And how the vectors can be have multiple directions? It means whenever you take the divergence, let's say this is a velocity. So if I want to know about that, at this particular point, how much velocity is just moving away from that point. So you will take the divergence of the particular velocity, and you will find out that yes, in which direction it is going on. So this is what the typical definition of the divergence in, and it has multiple directions, not the one direction. That why the divergence is not a vector quantity, it is a scalar quantity. So now what the fundamental theorem is saying regarding this is that, suppose that there is a divergence quantity, like this is scalar quantity. So this is what it says: volume integral of this particular t dv is equals to the surface integral of the t dA. So this is the fundamental theorem for the divergence. What is exactly says? As you can say here it is called the divergence theorem, and here you can see that it contains the volume and the surface integrals. It contains the volume and the surface integrals. So I know that you are not familiar much with these particular integrals, but let's see here in a very deep and quick manner that what exactly mean when we say that it is volume integral and this is this integral and this integral. So let's see here. So Volume integral is like this to find out the volume of any of the particular shapes using the quantity, using the integral. So this is what called the volume integral, and surface integral is also like same. Suppose that this is a surface and you have to find out the electric flux through that particular surface. So if you studied in the electrostatics that the surface, a closed surface integral of the EdA is equals to the Q upon E naught, I think. Yes, this is the formula. As you can see here, it means whole surface at how much electric field is pointing out from the whole surface. So this is the meaning of the surface integral. So suppose that this is a surface, then how much electric field is just moving out from that particular surface? So this is called the Gauss law for the electric field, and it tells us the electric field, how much electric field lines is passing through it. Okay, and this is the Gauss law for the electric field, but now we are not going to discuss this. We are going to discuss is that in the fundamental theorem of divergence says that if there is any of the quantity, divergence quantity this, and if you take the volume integral of this particular quantity, then what you will get is similar as you take the surface integral of that particular quantity. Suppose that I imagine a quantity, let's say t, and t is equals to the x square I cap plus let's say y j cap and z cube k cap. So here is a vector quantity t. Okay, so if you take the divergence of the vector quantity, you will get any certain value. So if you take the divergence of this particular things, what you will get is equals to the 2x I cap plus j cap and plus here 3z square k cap. Okay, so this is what you will get. So this is what you will get by taking the divergence of the t quantity. And if you take this integral and if suppose that you put down the value of this particular divergence in this equation and take the volume integral, this is just the same as taking the surface integral of this, taking the closed surface integral of this. So these two things are equivalent, and this is what the divergence theorem says, that both are same. You have the right choose to what method you choose to evaluate this. You can do this, that you can put down this particular divergence in this equation, take the volume integral. And another method is that you will just put, without taking the divergence, you can just put down the value of this particular t vector in this equation and taking the surface integral. Closed surface integral generally. So this is what generally called the fundamental theorem for the divergence. So if you're not familiar with the divergence and curl, again I'm saying watch my videos on that divergence and the gradient. So in the next video, what we are going to discuss is about the fundamental theorem of the curl. So this is a particular video on the vector operation. So thank you for watching my video.